Moving to our waste system. Permit me to quickly copy these guys to this other guy. Copy. So we now want to draw our waste pipe as well. Now, we've been provided stack. We've been provided a stack. A shaft for these wash basins that we have here. And also for this wash basin, we'll be routing it to these main shafts here. Now, let's quickly do that. I will click on my okay, so that we can see it in 3D as well. So I can see what's happening in 3D. I'll click on my I'll click on my bottle trap. So see here now, my bottle trap is telling me that the connector size is 35. However, our wastewater pipe, the minimum is 50 mm. So let's see if we can edit this family. So I'll click on it, edit type. Distance. I'm trying to see if we can edit the family in here. So no, it's not here. So what I'll do is I want to make this connector size 50 mm. Okay, it's here. So what I'll do is select all similar, all instances in view so that I'm picking everything. Let me be sure, yes. Then I'll change the diameter to 50 mm. Apply. Now let's start drawing our waste pipe. I'll click draw. Now I want to use this thing to show us something. 50 mm. You see that it's still, this is my waste pipe system. This is my wastewater pipe system, not my soil waste pipe system. However, because the system I used last was soil waste, it adopted my soil waste pipe system. A simple way to rectify this is I will click tab until I see dash lines. What that dash line means is that I'm selecting system. Now, let me show you something. If I click tab to select everything and I do delete, I'm deleting everything. But if I click tab until I see dash lines and I click delete, I am deleting only the system. So if I click on this pipe now, it will tell me there's no system on it. Undefined. Can you see that? Now, to make sure that this my pipe is on the right system, I can do right click, create similar, and select the right piping system, wastewater, and connect it to it. I also want to show something. Now, let me say, for example, I have, let me do PI, let me do 70 mm pipe. Now, you know, I'm picking 70 mm pipe. I'm drawing a 70 mm pipe. If I click on space bar, it's going to adopt the elevation and the properties of the pipe it's connected to. I hope you understand that. Let me go again. I'm trying to draw a 70 mm. I picked the 70 mm pipe to draw, connect to it, which you can see obviously is bigger than it. But immediately I press a space bar, it's going to adopt the elevation, the properties of that pipe it's trying to connect to. Now, let me move my pipe inside the wall. So that we can see what's happening in 3D. So I will draw my pipe. Remember that this pipe is at low level. I'll draw a 45. That's 135. So I want us to see what's happening in 3D as well. 145. I'll now change this elevation. I want this pipe. This pipe is going into the ground because you are discharging outside. Remember, my elevation it almost controls on my properties panel. I can see the associated parameters to my pipe. Now I'm saying in my mind, this pipe is going outside. So let's do negative 1,000. It's going outside below the ground level. Negative 1,000. Now my pipe that is going outside at negative 1,000 will not show yet. But let's see what will happen in the 3D. Okay, sorry, I did negative 100. Let me do negative. You can see what's happening in my 3D view. Now, I can just shift this a little to ensure that they are side by side. And let's say, remember that we have toilets on the first floor as well. So I can click on this and add a T. Let's check this in our section view. So I have my T now. I can say this guy is going all the way up, and it will have events. Now, we are done for this this wastewater pipe for the handicap toilet. Let's move to the other ones. The same thing we did here, we'll do here as well. So, pardon, I've not added angle valves and P-trap. So the ones here, Control V. Let me do rotate 90 degree, then move. Move. I want it to fall out the middle. Now, something is happening here. You can see that my bottle trap is showing above my toilet sink, which is not supposed to be in a real life scenario. So let's go to our section and see what's happening. My wash basins are on the floor. I'll click on them. Change my elevation. Let's do 600. Right? Let's say 650 for a more convenience, so that I have a P-trap connected to it. Okay, let's see what we use for our former one. Okay, we use 850. So let's just change this to 850 as well. So it's at 850. Now, permit me to just quickly select these guys and copy the space points. Let me look for a reference. Okay, I have my reference. I have my reference. Who can see what's happening here? This wall thickness here, DI dimension 200 is bigger than the wall thickness here, 126. So I need to adjust accordingly. So let's adjust this. Permit me to shift this wall forward. I'll just do AL align. 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 AL. So then I'll select them and just do copy. So I can move my sink back in place. Now, let's quickly model drainage, wastewater pipe for this system. Now I'll click draw, draw it out. Now, in some scenarios, as I said, we have different design concepts. Some people will tell you, draw it straight, it will slope and just connect with a T. It works. However, how I prefer to do it is I like a scenario where I will have minimum issues, because in scenarios where you have issues with your drainage on site, I like to have it at 45, as I said earlier. Then I'll draw. So let me confirm this. 85. Draw pipe. Then I will draw out this guy as well. So what I want to do is I want to draw out this elbow so that I'll be able to align it. Because if I connect straight into it, okay, let me just show it. If I connect straight into it, it's going to give me a T. Let me drag and connect into it. It's giving me a T. Personally, I don't, as I said, I don't want a T. So delete, delete, delete. Now, you see these pipes that are disconnected here. A shortcut I can use to connect them together is TR, trim extend, which you can find under your modify tool. You can see trim extend, TR. I'll click on that and select the two pipes and connect them together. So let me just draw out my pipe and align them to be directly above one another. Then I'll pick this my pipe and move it to an angle of 135, connecting to it. So I can decide to move this up a little. I can leave it this way. So on getting here, draw pipe, then go into our shafts. They'll do the same thing we did previously. We'll do negative 1000. Let's just, sorry, I forgot to match up with my 3D view so that we can see what is going on. Shift it. So let me get back here. So draw pipe. I want to change, we are going outside now. Negative 1000. Let's say we are discharging towards the front, which is wrong. It's supposed to be towards the back. Okay. Now, you see what has happened? So remember that we have toilets above as well. Then we add a T and also right click on the connector, draw pipe. So extend all the way to the roof. We are done with that. Now, I want to show us a quick trick. Okay, don't let me. The truth is, we are always working under pressure as engineers when you are assigned to design. And we like to, most clients will tell you, it's almost like a general rule of thumb. Every client will give you 2 weeks. Even if you are designing Burj Khalifa in Nigeria, I don't know where the 2 weeks comes from. It's always 2 weeks. So to manage time, what I will usually do is I will model a complete system. For example, my wash and basin, I'll have connected. Okay. So let's just proceed so that we learn it the right way. Let's just proceed to learn it the right way. Because the reason why I wanted to say that is because most of the times you're usually working under pressure. And as I said, the 2-week rule. How do you manage modeling that heavy amount of something? So we'll do it, but let's proceed with what we are modeling. What I can do is okay. So let's just proceed with what we have. Let's draw out our pipe. I'll do it. I will still do it. So I'll go to my section and turn it to a 45. Let me zoom in our 3D so that we can see what's happening. I'll turn this to a 45. 45. Then right click and draw my pipe. So I want to ensure I have the same level as this guy, AL align. So let me move it in place. Cancel. Now I have a very short room of connection here because this wall is 120 mm. So the trick I'll use is I'll shift my P-trap forward a little to give me a little bit of space. Then I'll do the same, draw out my pipe, a similar, make an elbow. Then I'll do align, go to my section and connect at 45. Line is too short. So let's see what is happening. 45. True. So it's giving me an error that the line is too short. Okay. I see what's happening. So what's happening is that because of how close this fitting is, so let me just do Ctrl Z, cancel. It's not giving me room to maneuver. So let me just shift it back a little. Click on this, then I will try to redo that again. Sorry, it's supposed to be 45. Thank you. So I'll move this back into place. It tells me it can no longer go. So I move my pipe and connect to my stack. I'll do 135. Then I'll do negative 1000 again to discharge to my manual, wherever that might be. Okay. Let me check the elevation I'm using. But I use negative 100 and see 1000. Apply. And let's not forget that we have toilets above as well, which connect to the stack. I go to my section view, click on my elbow, do the plus button to create a T, then draw pipe and take it all the way up. Now, I hope we are keeping an eye on the way it's coming out in our 3D view as well. So that we know, as I said, the way I like to design is, how will I install it on site? That's personally the way I like to design. Now, I'll go to my floor plan. So technically, I can say I'm done with my soil waste system for the female toilet on the ground floor. We can proceed to our water supply now. Can we? So let's proceed to our water supply. Now, was someone saying something? We can now proceed to our water supply.
Hello.
Yes, sir.
Please, are you missing out the floor drain? Is it not part of the drainage system?
Oh, thank you very much. So we have to add our floor drain as well. So this is a commercial toilet. Now, let me bring in my floor drain. Let me just drag it in. Permit me to drag it in. It's not best practice, but permit me to do that. So I'll add my floor drain. Drainage, floor drain. Let me see. I would like, I don't want to add, let me use this. So bring in this guy. So let me just add my floor drain around here. I'll drop that. So let me go to my section and check what elevation it is. So it's perfectly flush to the floor level. So if I click on it, 0 is directly on the floor level. So I'll go to my section. As I said initially, design is going to be at a later time, but this is modeling. So permit me to use 70 mm pipe for this. I am not calculating the size. I'm just using what I have. So let me edit type, change my connector to 70. So I can draw out my pipe. It goes all the way to my. So this is running in the floor. I hope you know that. So if we check it in our 3D, it is running in the floor. Now we can connect this to our stack. So that means I will need to change my stack to 45, sorry, 70 mm. That means me to quickly do that. Change the size to 70. Thank you. Then I can connect to my stack. Drop pipe. So let's see what's happening. Section 1, 70, 70. Now, drop pipe. Yes. Let me just show my angles 45, 135. I'll do AL to align it to the center of this. What I'll now do is I'll go to my section, look for where that floor drain is. I'll now do, okay, let me do it in 3D. So we can see this. I'll now do connect into, I'll do trim extend, but it will be a different form of trim extend. You can see that the symbol is different. I'll click this, pick my stack first, then pick my pipe. So my pipe is bigger than my stack. Let me see what's happening. So this is 50 mm. Oh, my stack is still 50 mm. Pardon me, I didn't change the size. So permit me to just quickly change the size of my stack. Sir? Okay, let me just change it to 3D view. So you can see now, we've not even started, we've not got it to clash detection. You can see, I can automatically tell that this my pipe should not be this way. So let me just shift this guy a little to the side. So just to ensure my pipes are not clashing. So in 3D view, tab, select, then click on this fitting, click on this, and change it to 70 mm. So let me try my trim extend again. Select and select. Now we are connected. Now we have our floor drain as well. So except for the male section that we are supposed to add the urinal, which we'll probably do as a take-home assignment. So, but I need to quickly move to water supply now. Now, I don't know if we have any questions so far. I'll just quickly take 5 minutes to answer our questions because I might not be giving room for breaks again. Any question within 5 minutes before we proceed? Okay, let's just quickly proceed. So let's quickly move to water supply. Now, as I said earlier, this is not a design class. So my design concept is as it is. Let me just put it that way. We are modeling. So I'm not sizing the pipes of my water supply. I will just draw them based on experience and things I know. Now, let me just quickly. Now we need to position our tank. We are designing a basic gravity system. So let's go to our roof level. So let me go to my architectural block plans roof. Let me just duplicate this, and add it to my plumbing plan. Apply. Okay. Now it should already be under my plumbing view. So let me just rename this roof. Now I'm just rename roof plumbing. Now, basic gravity system. We need a tank on our roof. Yes. So let me just quickly permit me to quickly drag in a tank, domestic water supply. domestic water supply, angle valve, intergate valve. Oh, I did not put the tank family here. Check. Okay, here. So let me extract this. Extract. So domestic water supply, water tank. Let me pick a basic water tank. Permits me to drag and drop in. So let me just put a tank on our roof. So this our tank is not having a connector. We can either model it that way and just show that our pipe connects to it, or we can do the right thing, edit family and add the connector. But this class is not for families. So permit me to just PI drop my pipe from the roof. So I think we need to locate where our shaft will be. So what I'll do is, for me to be able to easily locate where this shaft will be on the roof, I will do something. I'll go to my view. I'll go to annotate. I'll do a region, field region. As you know, Revit is both a drafting, a modeling, and an analysis tool as well. So this is the how will I call it? This is the drafting part of Revit. So allow me to just create another field region. Annotate field region. Let me do the same thing for this shaft here. I want to know where it will fall on my roof. Drop. Then let's get it as well. Okay. So what I'll do is I'll just change it to I make a solid map. So I'll do this. Then I'll do Control C. I'll go to my roof and do align to current view. So I know that this is where my shaft will fall on the roof. So I can draw my pipe towards that area, towards those areas. So let's say from my roof, let me use detail line to just say, let's map out our pipe. We want our pipe to supply. Let's say we have a pipe that will go to supply this section this way. It will go to supply the toilet separately, and it will go. So let's make it 2 because we have left side, right side. And as I said earlier, this class is not a design class, but this is the way I am proposing we route our pipe. Then we have another pipe detail line that will come towards this area as well. Okay, let's make it simple. So this is what I'm proposing that, okay, we are using a gravity supply system, and this is what we are proposing. So let me just do PI, pick my PPR pipe. As I said, I am not sizing this pipe. I'm just going by muscle memory. I'll pick 40, follow that part. Now, my pipe is not showing. Who can tell me why?
View range.
From view template, you not put it in domestic water supply.
The answer is my view range actually. So let me edit my view range. So go to, okay, see what's happening. I am drawing on the wrong floor plan because of my view templates. All this should actually be on my roof plumbing, not roof architectural. So what we just quickly do is select all these guys, Control C, then align to current view. So I will do PI again. it will be at a very low level. So let me just use 100. 40 mm from my pipe. Now, you see what's happening? Because the pipe I used last is wastewater pipe. It's a wastewater pipe system. That's why it's adopting this. So permit me to just Control Z. I'll do PI again. Pick the right system. I want domestic cold water system. Then draw my pipe to follow our proposed routes. Remember, we are going into the shaft, so we are going to the level below. So my level should be negative of my reference level. I don't know if you understand. Now let me move to my 3D view. So that we can see our roof. Now we can see our tank. Stop. Now I am supplying from above and I'm going to below. So let me just quickly. So with reference to my level, with my roof level, I am going down. Yes. So let me change it to negative 1000. Abi? We didn't check our section to know our roof height. So let's just say each level is about 4 meters. So that's, let's say, negative 8000 mm. 8000. Apply. Apply. So you can see our pipe in our 3D view. Now, let me quickly do the same for these guys. PI. Now, see something that is happening now. Because the elevation I used last was negative 8000, which you have to be very cautious of. If I draw my pipe now, it will not show because it's trying to adapt to the elevation I used last. Now, based on what I discussed previously, I can just do this. I don't need to edit it. I'll click space bar. PI is refusing to connect to it. What I can also do is just pick my pipe, create similar, and oh, sorry, I am picking detail line, create similar, then draw my pipe. So very quickly, negative 8000 as well. Apply. Very similar, draw pipe. I will get here. Let me say negative 8000 again. Apply. So let's go to our ground floor plan. My pipe should be in my shaft now. Let me delete these field regions. Now you can see that my pipes are now here. We now need to supply my fixtures. Now, based on design concepts, everybody has different design concepts. Some people believe they don't like pipes running in walls. Your pipe should come at high level and drop to low level inside your wall. So people prefer running pipes at low level in the wall. So you just have one pipe that will come from an high level, the rest will be at low level. Whatever design concept you have is as long as it's backed up by a standard. Now, PI. I want to start connecting my pipes now. As I said, I'm going based on muscle memory. 20 mm. I'll change this to 25. Now there's a family I'm supposed to add here that I did not add. I'm supposed to add a stopcock. Now, as I said, based on the design principle, if you are coming at high level to supply to low level, some people prefer to have their isolation valves in the ceiling. Some people prefer to have it at low level. As long as it's backed up by a standard, you are good to go. However, I'll be doing for the low level. So permit me to quickly drag in a stopcock. Yes. Okay. So this is my stopcock. So my pipe will come in at a. So permit me to shoot this guy so that I'm not having any clashes. Now, I need my small section to align this stopcock properly. I'll click on this, RO rotates, do 90. So I'll go to let's just use this guy. That's what I kept there. I'm just going to close some of these. So section 2, let me just move this into place. So I have my stopcock. I can Control Z. R2 to rotate. I'll do 180. Enter. Then I'll put this here. So let's see what's happening over here. So this is my stopcock here now. Now I want my pipe. This is the way I want detail line. I want my pipe to come at high level. Come here, then drop to low level here. Connect to my stopcock. Then from my stopcock, continue at low level to supply these guys. Now remember that we've not yet considered hot water system, our water heaters and the likes. But if we have a concept, if we have a good grasp of the cold water system, modeling your hot water system should not be difficult. Now, this is what I want to follow. So I'll do PI. Based on muscle memory, I'll pick 25. I want that pipe to come in. Okay. I want that pipe to come at high level. Let me say 2.5. I'll have to check. I have to confirm the elevation. 25. Connect to my pipe. Back. Then drop to low level here. So my low level, I'll say 200. Please just keep an eye on the 3D view. 200. Now you can see it has dropped to low level. We now need to connect into our stopcock. I'll go to my section that has my stopcock. I want my stopcock to be around, let's say, 300. So we need to connect into our stopcock. I need a section that speaks to that. Let me use this 90. So I can just click this guy and say connect into. I want yes, the lower side. Okay. So this, you can see that this stopcock I have used is small, but I'll just proceed with it either ways. So let me change this to 25. Now, my pipe, I'm also going to have a pipe that will now come out to low level. So now, this is where Revit gets interesting. As you're modeling, you're also coordinating as well. Now, from my section, you see that if I route this my pipe at, let's say, this 400 mm at low level, it's going to be clashing. It will probably clash with my waste pipe. So let's just do something a bit lower and say, let's say 370. I like rounded figures. Then I'll go to my plan view. Now we are 300. Now I think I can delete my detailed line now. You know the way we are routing our pipe. So I need to confirm which of my angle valves is the cold water. Okay, this is the hot water on the left. So it's usually the reverse on the hot water. It's usually hot water for cold water. So I'll drop pipe. So what I'll just do is, let me draw it all the way. I just do connecting. So I'll do this. I'll click this guy. I'll say connect into the cold water connection. Sorry, this detail line is interfering with my. Okay, this is the hot water. Sorry, so I need the cold water. Let me confirm this. My pipe size. No, I want it to be 20 mm. Let's quickly change this. I want it to be 20 mm. Let me just start and select shifts. I'm holding shift to deselect the ones I do not want selected. Shift to deselect shifts. Then I'll change this to, I want it to be 20 mm. So I'll click on my angle valve and do connect into. I'll pick the right connector that reflects where I want to connect it to. Okay, then pick my pipe. Now you see what's happening. The segment is too short because it's too close to it. So I'll do cancel. Because my pipes are not on the same level. If I move my pipe here, directly below my this guy, I should not have a clash, but let's just avoid it. Let me just, I can just shift it back a little too. So I'll pick this. I'll do connect into, pick the right connector. Okay, then pick my pipe. It's still saying the same thing. PPR, please check the routing, blah, 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 PPR. So let me move it back very well and see what happens here. So this is at 600, this is at 370. So let me move this back a bit. Let me connect into, let's see. Oh. What's happening now is what happened when we're trying to connect to our toilets. I don't have any 13 mm pipe. So two ways to it, either I edit my family or create a segment of pipe that is 13 mm based on my design. So what I'll do is just let me quickly see if I can change the diameter for this. So let me see if I can quickly change it to I can quickly change it to 13 mm. 13. Okay, let me just quickly edit the family and change it to 20 mm. Edit family, click on my connector. So it's telling me 12.7. Let me see. Where do I have 12.7 in the edit type? 12.7. Okay, let me just change it for me. So I'll click on my connector. I'll check what is controlling that size, diameter. I'll click on family type to edit. I'll look for diameter, 12.7. Please come again. Yes, if use you see this is a formula now. Let me see what's driving it. If use, so let me just change this to equals 20. Apply. Okay. Now my diameter connector should be 20. I'll do load into project and close. Do I want to save? No. Provide existing version and its parameters. Now my connector should be 20 mm. I'll now do connect into again or draw the pipe out. Either way I want to do it. Then pick my pipe. And we are good to go. That's that. Let me handle this 3D view so that we can see what is going on. So I've connected to my angle valve, then to my second angle valve, which is my second cold water system. So let me just shorten this a little. So I'll click on this again. I'll do connect into, pick the right diameter, pick the right connector, and connect into. And we are done with this section of the water supply. Let's say, okay, I want this same thing to reflect on the other side. Okay. Now, I believe we've been able to have a good, at least a solid foundation for plumbing modeling. So what I would like us to do now, why I said I wanted to show us, in a scenario where I am having a very big project, I need to model. Now, I can't be doing this one by one like every time. I don't know if you understand. So what I will usually do is I will model one section properly. Okay, let me just quickly do one for this You know, we have a hand bidet as well. It's similar. Put it here. Toilets. Let me just connect one of our toilets. So let's just create. Let me move this guy. Clashing with my soil waste. I'll move it here. Now, let's say I want this pipe to run at low level in my shaft to connect here. And keep in mind, I have to be wary of this, my soil waste that I already have here. So let's just quickly draw a section of pipe. Let me draw out this pipe. Draw out my pipe. I'll do AL to align it to my main riser, then connect into it. As I said, I am not sizing these pipes. I am just going off also memory. Draw pipe. So let's just draw a long extension of pipe to go all the way. Yeah, so I can now do connect into again and pick this guy. No pipe matching pipe segments. You see what's happening? My segments and sizes. So what I can just do is draw out a pipe from here. Connect it to this. Now I'll delete. It's not adopting the system, so I'll do tab. I just need I want to reference the elevation. So I can pick this guy and change it to I'll just create similar. Change it to domestic cold water. Domestic cold water. Because why I did that is I want to know the elevation. Oh, sorry. I'm very sorry. Create similar. Change it to domestic cold water system. I can pick this guy and delete. I'll do AL, so align it to this. Then draw it into this and connect. Now, what I was saying that I can't be doing this over and over. So what I'll just do is let me shorten this pipe segment. Let me do 30. What I'll just do is this. I'll do SL, which is slice, or come to modify. You should see your slice here. Slice split elements. I'll disconnect it here. Delete. Then I'll do tab to select everything. Then create similar. Pick a reference point. Drop. Now, all that is left for me is to trim extend to connect my pipe and shorten them where necessary. So these pipes overlap here. Let me change this to 50 to shorten it to 50 mm. Then I'll do trim extend again to connect them together. Shorten my section of pipe X to 30. I'll do trim extend to join them together again. Shorten my section of pipe 30. Trim extend. Then my last pipe will be an elbow. Delete, and the same way we can do plus to make a elbow a T, we can do minus to make a T an elbow. And that way, I've been able to save a lot of time instead of having to design, draft, or model each of them one by one. So now, finally, just to see, help you have a glimpse of what our templates can do. Come again? Okay, to mirror it. Yeah. Okay. So I don't advise that because engineer that I was saying that we can mirror to the other side, but what it will do it's going to flip the position of your hand bidet and the angle valve. So we have a hand bidet on the okay, it's even wrong. I put my hand billet on the left. It's supposed to be on the right. So I put it will now flip it to the opposite way if I do a mirror. But let me just trim extend. Okay, let's just do it. Tap, 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 select, and do mirror. You can either mirror with to pick an axis or draw an axis. So let me draw an axis. I want to pick a middle point.
Just to show you how they can optimize their work.
So you can see it has already mirrored to the other side. I don't need to start drafting all over again for this other side.
But for some features, it will work. Some it will not.
For some, it will not work. Then in scenarios where you have a single sanitary fixture where you have two connectors, it's going to flip their positions. So let me just quickly do TR to join these guys back together. And let's see what we look like in our 3D view. I think we've done a good job. We've avoided any clashes. We've avoided clashes. All our sanitary fixtures are the way they need to be. Now, just to quickly show you what our view templates, why we needed to create our view templates. Now, our plumbing template is our coordination template. Let's now say I'm putting my views on sheets now, and I want to see only my water supply. I'll go to my view template, change it from plumbing, and change it to, let's say, I want to see only water supply. Apply. You see what happens? I can't see any of my soil waste or wastewater system. If I change this to drainage and apply, I'll click OK. All my water supply system has disappeared. I already have my drainage system. You see the essence of this now. And if I want to do my coordination, I come back to my plumbing. You can have as many templates, as many view templates as required. Now, I think at this point, I don't know if you have any questions. Any questions as a way of rounding up? Any questions? I would like us to ask questions because, as I said earlier, it's in two ways. Is either I did a good job in passing the information, and the engineers are, my engineers are wonderful people, or I've said grip reach all through. So I would like us to ask questions. Okay.
Okay. So can I go ahead to ask my question?
Please carry on, sir.
Okay. So now, with respect to connection to the fittings, now I want to believe, I suppose we're going to have flexible connectors, and the like.
Yeah.
So how do you go about it? Are there templates for such?
Okay, let's just quickly do that. Thank you for bringing my attention to that.
We can't hear anything. No.
Oh, sorry. Let me come again, please. I was muted. So Control Z, escape. Let me do Control Z. Now, in your floor plan view or your section view, your drain a flexible pipe might not work. So, but in 3D, it works well. So I'll click on my angle valve. I'll right click on the connection point. I'll say draw flex pipe. Then I can now start creating segments for it. Okay, I want it to have I want it to be as realistic as possible. Let me just leave it this way. I'll click escape. I can see my flexible connection now. I'll go to my section view and connect it to my sanitary fixture. So let me see. So the thing here is this sanitary fixture does not have a cold water connection point, but let me just drop it somewhere close to it. Hope this answers your question, sir.
Yes, thank you so much.
Yes. So basically this is the way the connection is going to be made.
Another thing is, hello? Another thing is that you can actually draw a pipe and convert the pipe to flex.
You can also do that.
That's another. So there are so many ways to you can use to achieve that. But I think what is more important is that it is connected.
Okay, I would like more questions, please. At least 2 more. No question is so small. Please ask. My aim for this class is to ensure that at least 90% of the class is able to replicate what was done here. Please, whatever questions you have, whatever challenge you have in, please, I would like you to ask.
Okay, so let me
Hello.
ask a question. Okay, carry on, Jamil.
Oh, my own challenge is just being able to download this thing. I think I'm not finding it easy at all. Maybe it's something we can do together later. I don't want to bore you with that during this class.
Okay, download, what is that, sir?
The file, the issue I had earlier, I've not been able to resolve it.
Oh, okay, I will kindly reach out to me. You can reach out to me on.
Send it to him as an email. If you don't
Yes.
receive it,
Okay, you can reach out to Zach, the community manager,
The coordinator.
and yes,
Okay.
we'll discuss a way to resolve
send
that.
your email.
Okay, all right, no problem.
Okay, Mr.
I'll do
Abdul,
that. Thank you.
thank you very much, sir.
Okay, I wanted to ask regarding the this thing, the analysis. So I now remember that this is basically a modeling class, but the question still goes this way now. For instance, now that we are modeling this, after all the modeling and all that, then which step comes first? Is it the analysis or the modeling first? Are we supposed to do the model, finish all the model, then you now run the analysis? Is that the basic procedure?
Okay, so typically, when okay, let me say, Mr. Abdul, you want to build a house, you come to me as an MEP engineer to come up with something. The first thing I usually do is come up with a design concept. That's why I said, based on the type of building, we'll say, okay, we are using a gravity supply system, a boosted cold water system, maybe boosted from the roof, boosted from break tank. We are connecting to municipal. It's from there I'll now decide, okay, what type of system, what are my components I'm going to use. Then I'll move on to my calculations. But as I said, this class is a modeling class. We'll eventually get into building services proper. That's the design aspect, the design and calculation aspects of building services. Another part of this is that Revit has gained enough traction to the extent that they've made provision for third-party software to be able to help you carry out your pipe sizing calculations. So it has gotten to that point. Maybe in future classes we will explore proper analysis in plumbing system. For example, there's a VALC plugin that I can use to revalidate my pipe sizes for plumbing system. So maybe that will be treated as a later class. Engineer Dai also wants to add to that.
So thank you for that question. So the essence of this class is as much as we want to show how to do design, you understand, the time we have, we are limited. We can't also do how to size pipe and all of those things in this class. But the much we can cover, we'll cover it. However, the essence is just for us to, because most of the people that apply for this training are engineers that are already in the built environment and built professions. You understand? So what we tried to do was just to show how to use the software. There are other ways you can do your pipe sizing, and watch out for some of our trainings on how to do on extensive plumbing design, HVAC design, electrical design, and firefighting design. So we are just, as much as we can do, we are just trying to show you how to use Revit as a software for you to be able to do. And that's why he's telling you that he's using his discretion to use to do the pipe sizes, to just pick an arbitrary pipe sizes and all of those things. So what we are doing in essence is for you to be able to use Revit instead of you using AutoCAD to do your design. I hope that answers your question, or that adds more to it.
Yes, it has answered 100%.
So watch out for some of our training. We do pipe sizing, you know, and all those things in different ways. Revit. Revit also has the ability to do pipe sizing. However, there are some things you have to do to your family, which may be somehow advanced, and that's why we don't want to touch it as far as this class is concerned, because you have to load in your loading unit, load fixture unit, and all those things inside all those families that are in Revit for you to be able to do that. All right. Yeah, I just want to say something. Are you done?
Yes.
All right. Okay. And maybe I'm sorry. Or is it still here? What's the question? Let me just go. Okay, no problem. So don't divide the class, please. Let's finish. So thank you everyone for joining this class. Thank you everyone for joining this class. I just want us to everything he has done, I think we should go and replicate it. I want us to, after this class tomorrow, so you can do the other side of this. Let me move this. You can do the other side of this plumbing system for the ground floor. You can also go to the first floor and do the same thing. If you have done something good on the other floors, you should be able to replicate it on this side and also replicate the same thing that you have done. You can even copy them from below and copy them above if you know how to get across that. So maybe one of the things you will do tomorrow was how you can copy from one floor to the other if you have a typical floor, because it's more like a typical system. So you can copy from the ground floor to the first floor. So I appreciate all of you. I want you to, after this class, I want everyone to be able to use Revit for plumbing services, to be able to model Revit, plumbing with Revit. So, and I don't want you to fall my hand. I want you to complete this model. We will do HVAC, we will do firefighting in subsequent classes. And I want you, after you finish all your model, you share your model on LinkedIn, tag me, tag Vscope Engineering, and let's see that, okay, we have delivered our promise. I want you to be that we have delivered our promise. We want your contribution, we need you to contribute your part. We have delivered our own parts. And I believe we have done it as simple as possible. Tomorrow we'll continue. It's more like, do you see the way he's doing it? It's more like he's doing a project, a real life project. So it's not like he's encountering challenges and he's looking for a way, showing you ways to resolve it. So I believe you also have those challenges. So you can just go back to the video and see whatever you can do just to align with what he has done. I want you to complete this model and ensure that we have a good class at the end of the day. These 36 weeks should not go to, 36 hours, sorry. 36 hours that we are spending here should not go to waste. I want you to count for all of you. I need you to just clap your hand for our facilitator and tell thank you to him. Thank you, everyone.